Linear relations and slope. So some terminology that you need to know is that the definition of a linear relationship is the relationship between 2 points on a straight line. Slope measures the steepness of a straight line. You may remember slope being referred to as the rate of change. So it measures the rate of change. So in grade 9, you often use the rate of change as that phrase to represent slope. In grade 10, we use the word slope. So it measures the rate of change of one point with respect to another point. And you need to ask yourself, for every unit change in the x coordinates or the x axis, how much does the y change? And this will be dependent on the units or the scale of your graph. So when we're looking at slope, we need to look at something called the rise and the run. So the rise is the vertical distance between 2 points on a straight line. Run is the horizontal distance between 2 points on a straight line. So we'll review what that looks like. So when we're calculating the slope based on a graph, we want to look at the rise and the run. So in grade 10, you're going to use the variable m to represent the slope. So the slope of a line is referred to as the letter m. And to calculate the slope, we use the equation rise over run. So let's do a couple of examples just to review how we use a graph to figure out the slope of a line. So what you want to do usually is to, if you're a visual thinker, is to actually sketch out what the triangle would be if you were to turn this straight line into a triangle. So I've done that with this example here on the left-hand side. And then to calculate the rise, it's the vertical distance between these 2 points. So I need to look at how many units am I going up or down. So in this case, the rise from point A, if I was to label this point A, and point B, so I'm going from left to right, the rise is 1, 2, 3 units. It's because my scale is in, goes up by ones for my horizontal and my vertical axis. So now I need to look at the run, and the run is the horizontal distance between 2 points. So I need to look at the horizontal distance between these 2 points from left to right. So I'm going 1, 2, 3 units across as well. So my rise over my run is 3 over 3. And you always want to reduce your fraction into lowest terms. So you could write this as 1 over 1 because I can divide both of my numerator and my denominator by 3. Or sometimes you can even simplify this as 1 because 1 divided by 1 is 1, or 3 divided by 3 is 1. So we're going to now take a look at the line in the right example. So same thing I want to do is I want to sketch what this would look like if I was to turn this straight line into a triangle. Because then I can easily determine my rise and I can easily determine my run. So again, I'm looking from left to right. How many units am I going up? So 1, 2, 3, 4, 5 units because my scale is going up by ones. And my run, 1, 2, 3, 4, 5 units again. And 5 divided by 5 gives us 1. So we'll notice in this example, the length of the lines are different. So we can see that in the left example, we're only looking at a distance of a line that's within the first quadrant, whereas the distance of my line in the second example goes from quadrant 1 down to quadrant 3. So the lengths of these lines are different. So the length of the line is different, but the slope of the line is the same. And that occurs when, so we can either, it's one of two things happens. If the length of your lines are different, but the slopes of your line is the same, so when you have the same slope, then you either have two lines are the same, so they actually lie one on top of another, which this one will, or the lines are parallel. So remember, parallel means that the lines run beside each other and they never meet. So if the slopes are the same, then it means that the two lines are either the same line or the lines are parallel. So if you want to think about drawing a little diagram for parallel lines, you can do that as well. Okay. You may also remember learning about positive slopes versus negative slopes. So we want to follow the line from left to right, just as if we were reading a book, right? We always read from left to right, so we're going to follow our graphs from left to right as well. So when we follow the line from left to right, if the rise goes up, then it has a positive slope. So both of the examples above are examples of positive slopes. So it's going to be a diagonal line going up. So if this was your y-axis and this was your x-axis, this one has a positive slope, so it's going up. If your line from left to right, so if the rise goes down, then you're going to have a negative slope. So again, if I wanted to sketch a quick graph, as example would be a diagonal line going down. So this is an example of a line with a negative slope. So if it goes up from left to right, it's positive. If it goes down from left to right, it's negative. You may also remember learning about the slopes of vertical lines and horizontal lines. So if you have a horizontal line, then it has a slope of 0. So the slope is 0 because you're not going up or down. So this would be like walking on a flat surface. It's easy. And if you have a vertical line, so if your graph looks like this, then what we say is that the slope is undefined. So think about walking sideways up a mountain, or a wall. It's pretty impossible. So the slope is undefined because we can't make that happen. So these are just some terminologies and review of slope. So rate of change that you learned in grade 9 is the same as slope in grade 10.